For Lab 5, we're going to be looking at double replacement reactions. This includes precipitation reactions, acid-base neutralization reactions, and gas formation reactions. For the first reaction, we're going to react barium chloride with sodium sulfate. And so first I'm going to take about 1 milliliter of each of these solutions and put them in these test tubes. Okay, so we've got our barium chloride, sodium sulfate, and you can see these solutions are just clear, colorless solutions to start with. And I'm going to go ahead and take this sodium sulfate solution and I'm going to pour it into the barium chloride solution so that then they can react. And you could see right away it changed. And so it went from these two clear colorless solutions to now what looks like a white solution. Now, a lot of times when you see a cloudy type solution like this, it means that there's some solid floating around in it. Now, I'll go ahead and mix this a little bit, but then we're going to let this sit for a few minutes and see if a solid settles out. Because like I said, that cloudiness usually means that some solid formed, some precipitation occurred. And if you let it settle, you could either centrifuge it or give it some time to settle. You'll be able to see for sure is there solid in that solution. Now that we've given it lots of time to settle, you can see that the solution is starting to clear up, and we've clearly got some white solid down at the bottom of the test tube, whereas up here it's starting to clear up. There's still a little bit of solid floating around. It's taken a while to settle, but we definitely had a precipitation reaction occur. For the second reaction, we're going to take copper 2 sulfate and combine it with potassium carbonate and see what happens. So first, I'll do about 1 milliliter of each of these solutions in the test tubes. Okay, so we have our copper 2 sulfate, and you can see that's a clear blue solution. And then we have our potassium carbonate, and that is a clear colorless solution. And so I'm going to take the potassium carbonate, and I'm going to pour that into the copper 2 sulfate solution. And you can see it's still blue. It's maybe a little bit different shade than it started, but it doesn't look clear anymore. You can't see through it. But let's do a little bit of stirring. And so it didn't really change with the stirring, but it still just looks like this solid blue type solution. You can't see through it. But if you look really close, you can see it's got stuff clinging to the edges of the test tube where I stirred. And that's because there's some solid in there floating around. And I caught some of it on the stirring rod, and it's up on the edges of the tube. But just like the first one, we'll go ahead and give it a few minutes, give it a chance to settle a little bit, because the solid in there should start to settle to where you can tell definitely there's solid in that solution. Now after letting it sit for quite a while, you can start to see it separating. You can see a little bit of the solids still floating at the top, but you can see kind of that clear line at the top, and so that's where the solid's finally settling out of that solution. Now for the third reaction, we're going to react sodium phosphate with potassium chloride. And again, I'm going to put about 1 milliliter in each of these test tubes to start with. And if you look at those, you see that those are both clear colorless solutions to start with. And so I'm going to take the potassium chloride solution and I'm going to pour that into the sodium phosphate solution. Okay, so we started with a clear colorless, or 2 clear colorless solutions, and it looks like we still have a clear colorless solution. And so it doesn't appear that anything happened and there weren't any bubbles formed or anything like that. Just, when we first mix that, and it also, the test tube, it's not warm or anything. So based on the observations, it appears that nothing has happened. Now you can still look at the actual substances and predict should something actually be happening that is unobservable. For the fourth reaction, we're going to react HCl, or hydrochloric acid, with sodium hydrogen carbonate, which is NaHCO3. And so again, we'll take about 1 milliliter of each of these solutions. And as always, you should make note of what these solutions look like to start with, which they're both clear colorless solutions. And I'm going to take the sodium hydrogen carbonate, or sodium bicarbonate, and I'm going to pour that into the HCl and see what happens. Okay, so you could see when I poured that in there, it started bubbling right away. So there's definitely some sort of reaction occurring because I'm not heating this test tube. But when I poured the sodium hydrogen carbonate in, it immediately started bubbling, fizzing, and it's still a little bit, you still got a little bit of bubbling occurring. The solution still appears clear, but that bubbling indicates that some gas must be formed in this reaction. Okay, reaction number 5. We're going to take a solution of cobalt 2 chloride and combine it with a solution of sodium hydroxide. So that's cobalt 2 chloride and sodium hydroxide. Again, about 1 milliliter of each. Okay, and before I mix those, you should take note that the cobalt 2 chloride is kind of this clear pink solution, or even when you look at the bottle, it seems almost red, but it's kind of a clear pink, and then here we have a clear colorless solution for the sodium hydroxide. And I'll take that sodium hydroxide solution and pour it in the cobalt 2 chloride. And immediately you should have seen this change. And so you can see it looks kind of cloudy, or it's got this weird texture in there. I'll go ahead and mix that. And then we're going to give it a few minutes to sit. Give it a few minutes to sit and settle because you see that kind of speckling in there. That looks like there's some solid floating. So we're going to give it a little bit of time, see if it settles. So see if this kind of bluish turquoise coloring settles as a solid. Okay, so I've given it several minutes and you can see that it's settling. It's still in the process of settling, but you can tell that there's some solid there. It's this greenish blue turquoise color solid that's now settling to the bottom. So this definitely was a precipitation reaction that occurred between the cobalt-2 chloride and the sodium hydroxide. Okay, next up for reaction 6, we're going to take hydrochloric acid and react it with sodium hydroxide. Okay, so I've got about 1 milliliter of each. We've both got clear colorless solutions. I'll take the sodium hydroxide and add that to the HCl. Okay, so we started with a clear colorless or 2 clear colorless solutions. We still have a clear colorless solution, and if I stir that, see it's still clear and colorless. And so just an outward appearance, it doesn't really look like anything happened. But again, we had that happen with another one. And I said you should look at the compounds and you can predict if a chemical reaction would actually happen by predicting what could be formed. And then based on what could be formed, you determine, did something really happen? And is it that something happened and it's not observable to us? Okay, reaction 7, we're going to react copper 2 sulfate with sodium chloride. Okay, so our copper 2 sulfate, as we've seen before, is a clear blue solution, whereas our sodium chloride is a clear colorless solution. So I'm going to take that sodium chloride solution and I'm going to add it to the copper 2 sulfate solution. Okay, and it looks just like it's still a blue solution, but let's go ahead and stir that. Okay, so it doesn't look like anything happened, at least not that we can tell by eye. It's just this clear blue solution. It maybe is a little lighter than it started because it's been diluted, but it doesn't look like it's changed in any way. So just like before, it doesn't appear that anything has changed, but that doesn't necessarily mean nothing happened. You'd have to predict the products of this possible reaction and determine, did something occur that we wouldn't actually be able to see with our eyes. Okay, reaction number 8, we're going to react cobalt 2 chloride with sodium carbonate. Okay, and the cobalt 2 chloride that we're starting with, that is a clear kind of pink solution. The sodium carbonate is a clear colorless solution. So we'll take this sodium carbonate solution and pour that into the cobalt 2 chloride. And we definitely have a change. It immediately changed kind of this purplish color, and right now it looks a little swirly. I'll go ahead and mix it. So it looks like you got some purple and almost some bluish color in there. Okay. So we've got it mixed, and like we've seen with some of the others, now it's kind of this colored solution. It's this purplish blue, but it's not a clear solution. You can't see through it. It's kind of cloudy. And so that indicates there's likely solid in there. And actually, if you look a little higher on the tube, you can kind of see that from me mixing, there is some solid stuck up on the edges of that tube. So we'll give it a few minutes to kind of settle and see what it looks like after giving it a chance. Okay, so I've given it several minutes to separate. It's still not separated all the way, but you can see some of the solid at the top and then some of that purplish solid sinking down to the bottom. So some's kind of trapped at the surface of the liquid, but the rest is settling. So we definitely had some sort of precipitation reaction occur. Okay, so the final reaction, reaction number 9, we're going to react sulfuric acid with sodium hydrogen carbonate. Okay, so both of our starting solutions are clear colorless solutions. We're going to take the sodium hydrogen carbonate solution, and we're going to pour that into the sulfuric acid. Okay, so you could see right away it started bubbling, and so there was some gas formed causing these bubbles, and it's continued to bubble. It's finally kind of fizzling out. We did start with clear solutions. The final solution is still clear, but that bubbling indicates that something did in fact happen. Some gas formed, and even as I disturb it there, I get it to react some more. And so you've got lots of bubble formation, so lots of gases, or lots of gas being formed in that reaction.